You know the scary part of all this business, you see it and I see it every day, is the ones that have no idea they want to be in the restaurant business. And they go online, I want to be in the restaurant business. They read 2 articles and away they go.
Hello, everyone. Welcome back to another episode of Mastering Restaurant Revenue, the podcast where restaurant dreams meet real-world strategy. We're your hosts, Bruce Russo and Diane Armitage, and we are continuing with questions that have come in from recent episodes. So we've already finished a part 1 that we've already published, and we are randomly answering these many questions that have begun to pour into our YouTube channel comment section and our masteringrestaurantrevenue.com community. When you sign up for masteringrestaurantrevenue.com, free, and you can enter all kinds of questions there as well. So today I'm going to be asking Bruce, there's a few questions for me, more questions for Bruce. I'm going to be asking Bruce these random questions. We haven't participated in any kind of a rehearsal. We're just doing this off the top of our heads. You ready, Bruce?
Man, I got a gun to my head. Fire away.
Fire away. Okay. So this one comes from Todd in San Diego. He said, we inherited a second-generation kitchen full of gigantic wok equipment. We definitely have a hood there, but if we're replacing the woks with our grills and such, the hood can stay as is, right?
Well, no, that's not right. Well, you can use the hood, but it'd be senseless to use the hood. Typically, if there's a wok, the hoods are 2 foot bigger, meaning the standard is 4 foot to 4'6". Typically, a wok hood is 5.5 to 6 foot away from the back wall because of the heat. Number one. Number two, the BTUs of a wok are probably 3 times that of any kind of regular equipment that you can put under the hood. Plus, the CFMs of those hoods are probably 3 times more than what you will need for a regular restaurant.
What's a CFM?
It's the airflow through the exhaust.
Okay,
cubic feet. And so I don't know what your concept is. I don't know if you're going to have wood fire grills or whatever it may be. If you have a wood fire grill, then yes, those hoods would probably work. And you can adjust the CFM of the exhaust and the makeup air by adjusting the size of the pulleys. And I mean, there's all kinds of things. You're going to have to get a mechanical engineer involved so you're not sucking all of the air-conditioned air of the dining space of the restaurant up the hood.
Well, typically
the exhaust on a wok hood, those are huge CFMs. I mean, it's probably 3 times more. And the whole goal with exhausting over the past 5 to 10 years, it's all about energy efficiency. So the hood designs and the way we do things now and the way we channel the makeup air helps reduce the amount of CFMs of exhaust. So with this wok concept, I would definitely hire a mechanical engineer to take a look at what you're looking at before you make a commitment on signing a lease.
Okay. I'm going to skip ahead to some other questions because you just started talking about makeup air, and this is one of the main questions that people have been asking us. So I'm going to skip ahead to a couple other people. And I think all of this is stemming from our episode 3, which was called Renovations, Rats, and Money Traps, which focused on helping you, before you sign a lease, helping you sort out this kind of stuff before you get into a lease and realize that you've got a lot of work that you've got to do on your end to get something up to speed for your concept. Correct. Okay, so let me ask you this, since we're talking about makeup air. Al in Houston, he says, it seems like every restaurant I visit, I can smell sewer gas. What is the major cause of sewer gas? And then the second question is Mel from Albuquerque. He says, can you explain the science behind makeup air? You've mentioned it numerous times, and it seems like a very important thing that seems to be overlooked a lot of times. So I think your answer here, Bruce, is going to fold all of this in.
Okay, and it is. It's very important. So any restaurant that has an exhaust hood, you have makeup air and you have exhaust. Probably the two most important things to operate a restaurant is makeup air and exhaust. And they have to be balanced properly. Okay, just because you put those two in, you have to have a balance engineer come and balance the makeup air, the exhaust air, and your fresh air intake on your HVAC. All
Okay,
those
so
three categories.
let's talk about makeup air and exhaust air. When you're defining this for a new restaurant owner, tell them what that means in new
Okay,
restaurant owner speak.
exhaust is the exhaust that goes up the hood. The
Mm-hmm.
amount of exhaust is calculated by the engineer based on the BTUs of the equipment, the heat, the BTUs that the equipment is expelling under that hood. Okay, so that CFM, that includes the heat, that includes all of that, that is calculated as a number. Then
Mm-hmm.
that number is transferred to the size of the exhaust hood that goes on the roof. If you need one, if you need two, if you need three, based on the length of the hood. So you have equal suction across the whole length of the hood. Okay, so if you're sucking air out, the makeup air is putting the air back into the space that you're sucking out. So what the makeup air does, it replaces 80% of the air that's being sucked out by the exhaust system.
Okay.
The other 20% comes from the dining room itself. What we want is a positive space, meaning that, and here's a simple check. When you walk up to the front door of the restaurant, just open a door an inch. If you feel air against your face, it's perfectly balanced and it's positive. If it's negative, when the restaurant is negative, that means the makeup air is not balanced correctly.
And how
Okay,
can you
so
tell at the front door?
at the front door, if it's negative, you have to
Mm-hmm.
pull on the front door. And when you open it that inch, instead of blowing air at you, it sucks your hat off into the crack. Okay, so now what else does that do? Well, that balance, the balance being wrong on the makeup air is probably the culprit of 99% of the time you smell sewer gas. Because believe it or not, the hood is going to suck air from somewhere. And if all the doors are closed, the sewer system, everybody thinks the sewer system is filled with water. There's nothing in the sewer lines but air. And that's, if you knew how a sewer system was engineered, the vents go to the top. So the vents that go to the top let the air flow in the pipes freely. The only thing that has water in it is a P-trap. Okay, so if all the doors are closed and the hood's sucking air and the makeup air's not making up for it, it pulls air out of the sewer system. And it doesn't matter if there's water in the P-trap or not, it will suck the air. You can actually watch it make bubbles, and the air comes through the sewer system and into the restaurant. All the floor drains and all the floor sinks. So typically, if it's a 4,000 square foot restaurant, there's probably 20 outlets in the floor, sewer outlets in the floor between floor drains and floor sinks that the hood's going to suck air of. I mean, it's a pretty big source.
Wow. That's really interesting. Kind of greedy, that makeup air part.
Oh, and you have to feed it, and it has to be fed properly. Otherwise, it's a complete disaster.
So what happens when you say a complete disaster? If the makeup air isn't working at all, and if you're not feeding it properly, what happens?
It sucks air it sucks air conditioned or heated air from the interior
Okay, so then you're
restaurant.
paying. Then you're paying a
Then
lot
you're
of money because you're having
exactly
heated air and air conditioned air going
because
up
it's
to the
totally
makeup
inefficient.
air.
Correct. It's
Right.
totally inefficient. Now, when somebody opens the door, that whole restaurant goes until the door closes. Every time that door opens, the restaurant goes, ah, because when that door is wide open, that's a 21 square foot opening that just fed air directly into the makeup air, into the hood. I know it sounds very
Okay.
simple, but
No, it
engineering
doesn't sound very
wise,
simple.
it's not simple, but this is common mistakes that people make again and again and again and again. I mean, and everybody thinks, well, what do the big chains do? Well, let me tell you something pretty amazing. I worked with one chain that probably had 80 units across the country,
Mm-hmm.
and they all had 4 air conditioning systems on the roof throughout the restaurant.
Mm-hmm. Mm-hmm.
Okay. They had thermostats in the manager's office, but the thermostats weren't connected in the manager's office. The thermostats were inside the unit on the roof, and they would send a signal to a satellite receiver at the main office. Out of all 60 stores, all the lights and all the air conditioning was controlled in one main office.
That's amazing. Would you say that's efficient?
Well, because they set the efficiency.
Right.
So if somebody came in and said, wow, it's chilly here, can you turn the air conditioning up a little? Oh, yeah, sure. I mean, the manager goes back there and he presses the up button, but it's not telling the unit to do anything.
No kidding.
It does nothing. No.
Wow.
The entire
So it's
dimmer
being controlled
system.
by a god somewhere else.
Exactly. And there was one person that sat in one room, probably a 12 by 12 room, that had computer screens floor to ceiling. And that's all he did was monitor it all day long. And if for some reason the temperature range went out of range that they had set on the device that was monitoring the temperature, they'd get a red signal. And then that meant either the unit has broken down or the unit's not functioning. I mean, and this is like 15 years ago that technology was developed. So it's probably times 10 now. I mean,
when you're thinking of 80 restaurants and having a single control room for the air conditioning and the heat, which is also in some way, shape, or form monitoring the makeup air and the exhaust air, I would think.
yes,
right?
It does everything. Yes.
When you have 80 restaurants and say you've got half of the restaurants off with the AC capacity, how many more thousands does that add to their bill?
Okay, when they completed installing all the sensors and the entire system,
Mm-hmm.
they cut their utility costs by $3.5 million a year. Yeah.
No way.
Okay, but let me tell you what else they did. Once they had the proof of that savings, they went to the power companies and said, look, we've put this system in. Here's our data. Now we want wholesale. We want wholesale power.
How smart was that?
And they give them, I think, a 20 or 30% discount on their power.
Wow. And they still have 80 units or so running?
Oh,
out
no,
there?
they probably have 120 now by now.
Incredible. And so does the restaurant manager know that if he says, okay, yes, I'll turn off the air conditioning, does he know that there's nothing he can do? He just pretends to go back and turn it up?
I don't know if the managers know or not. I don't know.
Now you may have let a really big secret out of the bag.
Well, maybe so. I mean,
yeah.
but all the dimmer panels, all the makeup air, all the exhaust fans, all that, all of them had monitors put in them.
That is unbelievable.
I mean, they're not the only concept doing it now, because when it caught on, I mean, when you're saving $3.5 million a year, I don't care what size company you are, that's a lot of money.
Well, and when they went from retail to wholesale power, when they negotiated with the power companies, how much more do you think they saved there?
30%.
30%.
They got a 30% discount on their overall rate across the board. And that's when power was just starting to get deregulated, and so it all connected. The system that they put in, all the monitors that they put in, it was a capital expenditure because they knew the rates were going to be freed up across the country,
Uh-huh.
and you could actually shop power. So they went to one vendor and bought all their power from one vendor. How that
No
vendor
way.
supplies the power throughout the country, they don't care. They got the rate. It was
Unbelievable.
genius.
Wow.
I mean, it was genius. But there was probably 6 engineers involved in that whole program for
Uh-huh.
probably it was about 18 months. Took them about 18 months to put it together. I don't know the
Yeah.
capital cost of what it cost, but I can tell you that I think the first year of savings pretty much paid for everything.
Oh, indeed. Absolutely,
Yeah.
indeed. Otherwise, they wouldn't have done it, you know? But
Yeah.
man, so this feeds into another quick question about Stan from Erie, Pennsylvania. He says, is there a magic formula for figuring out AC capacity for a restaurant?
Oh, absolutely. Yes, there is.
How do you do that?
Okay, so first of all, it depends what zone you're in. The United States is laid out in zones, and
Mhm.
it's temperature zones. And so in them zones, we flip the page and we can look at the data. We know what the humidity is. We know, what we call a dry bulb and a wet bulb. And I mean, there's probably 10 items that we look at when we're engineering HVAC. And so all that data creates formulas that we use to size the AC units and the heat. So
Hmm.
let's say we're building two 8,000 square foot restaurants. One's in Erie, Pennsylvania, and one's in Dallas, Texas. The one in Erie, Pennsylvania, you probably need three HVAC units on the roof,
Hmm.
heat and air, rooftop units. In Dallas, you're going to need 6. Just because of the data, they don't have that many 100-degree days in Erie, Pennsylvania that they do in Dallas. So when it's 6 degrees below zero in Erie, Pennsylvania, and that makeup it's just air pulled off the roof,
Mhm.
when it's not tempered, that's not a working environment that any human being wants to work in.
Right.
Because
So as
there's
it comes in from outside, it has a heating thing involved in the actual
correct.
equipment.
If the hood is you're correct, if the
Mhm.
equipment is purchased properly and it's engineered properly, there's a furnace and air conditioning unit in that makeup air unit that conditions the air before it is expelled into the hood.
Oh, that's really interesting because I've actually been in restaurants with the big wood grills where
Yeah,
they've got fire all the way
yeah,
across for like 12, 20 feet, and they're
yeah,
dying back there.
yeah.
Yeah, because they haven't worked that into the equipment.
Correct.
If they actually came in and had a hood with the exhaust and the makeup air, I know this probably sounds like a really mundane question, and they said, okay, well, we're switching it from wok fire to grill. And you had just said, the wok would probably work with fire grills. But if a fire
Would
grill is like super heat, is
yes.
there a way that you can insert that kind of heating, air conditioning into the equipment itself? Or do you have to go
Well,
get a
so what
whole
we
new?
do is when we engineer the hood, this is
Hmm.
the face of the hood.
Hmm.
How do I do that? We put the makeup air here, and this is the bottom of the hood right here. That
Uh-huh.
air goes directly in. It's engineered
Okay,
to
got
go.
it.
It's engineered to go no place but into the hood.
Huh.
So and if you've been to some of the seminars, the hood seminars I go to, they use red smoke and blue smoke for the makeup air, and you can see the red smoke exhausting out, and how they engineer these hoods to where right at the edge of the hood, that blue air turns right up there's a switch that turns it to go right up into the hood. It never goes outside the hood. It goes
Huh.
directly into the hood. That's the efficiency. I'm telling you, over all the years I've been doing restaurants, they're built like a spaceship now. They're engineered and built like a spaceship.
Wow, that is just absolutely amazing. And what amazes me even more is that you actually go to hood seminars
Yes. You
and
do
watch the red smoke and the blue smoke.
well, but see, they look at me like, I come to them one time and, I was designing a restaurant. It was the structure was round.
Uh-huh.
and it had a second floor balcony. And it was a Michelin star chef, and he wanted to put a restaurant in there. Well, when I was designing the restaurant, he was going to be on stage, but 60% of the seating was on the balcony. So if I put a stainless steel hood, you wouldn't
Right.
see him. So I designed the exhaust system out of glass.
Remember you told me this story.
And
So you went and asked these guys if you could do this
I
out
went
of
to
glass?
Captive Air. Yeah, I went to Captive Air and said, you know, this is one of those what ifs, guys. You in or not? And they were in it.
What did they say?
Yeah, no, we did. They designed it.
Really? Had it been designed before?
Well, no, they never done anything before like that. So really, it wasn't that hard to engineer it. It was finding the right material, because all we did was replace the stainless steel pieces with glass.
Yeah.
But the louvers that catch the grease, we had to take those out. We had to take that section of the hood out. So what we created was just a radiused. It was a radiused glass hood that once the duct was connected, you could still see the chef, and all the grills and everything were above that. So we basically made two hoods. The glass hood was the hood that captured the smoke and grease above the cooking equipment. Then directly above that was another hood that exhausted everything out of that glass hood.
That is really unique. I've never seen a glass hood. And it didn't have any cracking or any issues at all.
No, because I had Corning. I had Corning involved. They wrote the glass spec, and they worked with PPG writing the glass spec. And the hood was 1/2-inch thick glass that was laminated tempered.
Did you get a patent on that?
No.
I mean,
No, but you say you never seen one. That's probably one of the most unique things I've done in the restaurant business.
that is really amazing. Okay, let me ask you one other quick question. Now, since we're talking about mechanical,
Okay.
what we have, who is this gentleman who asked? Mike from Memphis. What is better for a restaurant, electric heat or gas heat?
Electric heat is much cleaner. In my opinion, gas is much more efficient. But there's areas in the country that still don't have natural gas, and all the cooking equipment has to be electric too. So, I feel for the people that live in those areas, but you can surely function a restaurant with all electric.
But when you've got gas in the kitchen, you typically do electric in the front of house, don't you?
No. Typically if we got gas there, we let gas be the main component, and we do all the RTUs, all the air conditioning, the furnaces, and the water heater as gas. Gas-fired water heater is a much more efficient than electric. If we got an all-electric situation, or if the gas size to the building is minimal and we don't have enough to do the kitchen and all the accessories, then we'll flip to electric. But typically, if I can't have electric hot water heater, I usually use 100-gallon quick efficiency gas. If we can't do that and we have to use electric water heaters, then I'll put 2 100-gallon side by side and connect them in a loop. Yeah.
Wow. It is interesting how every kitchen solution is a custom. Every restaurant solution is a custom.
Everyone's different.
Where your zone is, where you have gas and electric, it has a lot to do with the region and where you're actually putting the restaurant in play.
Okay, so the scary part of all this business, you see it and I see it every day, is the ones that have no idea they want to be in the restaurant business. And they go online, I want to be in the restaurant business. They read 2 articles and away they go. And, you can sit and talk to me. I can give you details after details after details of detail. And It's the engineering portion that makes it work. And if it's not
Yes.
engineered properly, I don't care what you're making, French fries, it doesn't matter. PB&J, if it's not engineered right, it's costing you money somewhere.
Exactly. And you build restaurants to do what?
Make money.
Make money. That's
And
right.
part of that theory is, okay, I'm here to make money. You're not here to repair things daily.
Mm-hmm.
So when you talk about capital expenditure, that's not cash flow from when you open. Capital expenditure is green money. Cash flow from when you open is blue money. Okay, that pays the capital bill at the end. It's not part of the capital bill. So is there a difference between spending 2.5 million versus 3 million? Well, absolutely. That's the difference between a restaurant built wrong or a restaurant built properly.
Exactly.
And so, we get these clients that, I got a budget of 2.2 million. Well, who made that budget? Well, I checked around and people say, it costs this much a square foot to build a restaurant. Brother, you need to cover your ears when people say that. I've never seen a restaurant cost per square foot anywhere be exactly the same as the one next door. It doesn't work that way.
Correct. Well, and it's interesting too. You work with a large chain. I don't know. They may have 20 restaurants now. They may have more. We're not going to name the chain, but
Right.
I mean, they are building in all different regions and areas, and
Yes.
they could go in and say, well, we're going to do 4,000 square feet here. 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 All the expenses would change.
Everyone would be different.
The whole cost of the bill changes.
Yes.
Because
Everyone would be different. Yes.
Everyone is different. And so if you
Yes.
think you're going to get into building out 80 or 120, understand that you can have a cookie cutter, but the cookie cutter still has to have.
Correct. And we've done the cookie cutters, and the cookie cutter plans do stay the same, but you have to site adjust for whatever zone you're going in.
Right.
And although the architectural plans typically stay the same, the engineering plans don't. That's what totally changes. Okay. So let's say you picked you're going to do a ground up building. You bought a site. Did you do a soil test? No, I didn't think we needed one. Well, let's go ahead and do a soil test. Well, guess what? We got caliche soil that actually triples in size when it gets wet, which means what we call the LER, the rise factor. Okay, the vertical rise (PVR) is it's a potential vertical rise. When it gets upwards of 12 to 14 inches, you have to adjust the building for that. And guess
or you
what?
have a cracked building.
It comes apart. And the problem with everybody forgets, the plumbing in the street is below that soil that's moving. So when you bring the plumbing into the building, you have to accommodate for that. The water lines and the sewer lines are moving too, because they don't stretch.
They don't stretch. Until you create that, you're going to have to figure that one out.
Correct.
Correct. No, it is absolutely true. And we could tell another tale of something like that happened with you recently with a client. But you know what? I'm going to do that. I'm going to do that in the next episode, because the next episode we're going to talk about how you work with clients, and when you walk away and when you stay with clients, and some of the things like these clients who decided, well, the soil expands and expands and they didn't accommodate what the engineering plan required.
Yeah.
So, no,
we just went through one of those.
Yeah. Okay. So all of this talk that we did would be in two of our episodes. One episode was episode 3, renovations, rats, and money traps. And then we also did one on leases and before you sign the lease, because the mechanical is so important to understand, especially in second-gen restaurants, third-gen restaurants, what you're getting into before you sign the lease. And I'm afraid I don't have the episode number in my head for what lease that was, but it was in our first 5 or 6. Yeah. So go back, listen to those episodes. You can find our Mastering Restaurant Revenue YouTube channel, audio podcast platforms, audio podcast on YouTube. And I think we even do, and our masteringrestaurantrevenue.com is where we dive more into how you can immediately apply what we're teaching and what we're talking about into your daily business. Okay, so with that, we are going to close this episode off. Thank you again for answering all these great questions, Bruce.
Absolutely. Keep firing.
We will. We will get into another episode. And thank you all for sending in all of your questions, and hope this has been of help. Thanks for coming to Mastering Restaurant Revenue, and we will see you next week. Bye-bye.
Thank you.
Thank you for joining Bruce and Diane on this journey of mastering restaurant revenue. Please take a moment to like, subscribe, and share your thoughts in the comments below. Your feedback helps them deliver even more of what you want to hear. Until next time, keep refining your approach, stay passionate about your craft, and here's to your restaurant's continued success.